Hi and welcome to Unit 2 Topic 3 Video 5, and in this video we're going to be looking at univariate data and looking at some sketches for data types, starting of course with our favourite, categorical data types. Enjoy! So for categorical data there's two main types of displays that we use. And it's not unreasonable to use a pictograph or even a dot plot, for example, but typically we use what's a bar chart or a column chart or a pie chart. Now for this, for General Maths Unit 1 you won't need to be able to use a pie chart, but you might need to be able to use what's called a column chart in this syllabus, and it's basically just a bar chart. So let's imagine I've gone a survey, people's favourite colours out of the very restrictive 3, pink, orange and green, done by colour. So let's say that we've got a scale. We should always have a scale here, which I'll do in pink. 1, 2, it's a pretty exclusive survey, 3 and 4. And then pink is chosen by 2 people. So the way I'm going to draw this is just do my little top bar, and then obviously with a ruler draw my bar down there, and I might even colour it in to make it obvious. And that's pretty easy to read. Orange is really popular and chosen by 4 people. And I can do the same thing and then colour my orange in. And then of course I've got green, and green is not so popular and it's only chosen by 1 person, so it goes down here. And this is what my bar chart or column chart will look like. Now we have to remember in this case that we can't really talk about, which we're going to talk about later in this series of videos, the skew or the shape of the data, because it's categorical, and in this case it's categorical nominal. So that means that pink, orange, green could be in any order and it doesn't matter. So the fact that our tallest bar is in the middle does not mean it's got a nice even distribution. It's completely random that I put orange in the middle. And in fact the data I made up, so it's completely random, full stop. But this is what our bar chart would look like. As long as we're neat, we've got our arrows, and then we might also label our axes here with things like fave colour, maybe it'll be a little bit less informal, and then up here this is our frequency, and this could also be our percentage frequency. If it was our percentage, this would be about 57%, I believe, is 4 out of 7, and then this will be about 43%, and this will be about 28%, and this is about 14%, and something like that. So this could be a percentage frequency as well, or it could just be frequency. And of course then we have our pie chart, and so in our pie chart we have a central point, and then if I split it into quarters there's 7 pieces, so it's not going to be perfect. We could go through the pie chart, we can work out the angles, but you don't really need to know it. I just want to illuminate the fact that it's another way of representing categorical data. So we're going to have, if I start here, a little bit over 1/8, so this will be our green, and then a little bit over 2/8, this will be our pink, and then the rest of course is our orange, and that's just a representation of the same data. So categorical data, nominal or ordinal, can be represented by either of these 2 charts. For this syllabus you'll need to know how to use a column chart. Of course if it's ordinal then we would probably put these values into order. Other than that the rest stays the same. Make sure you're labelling your axes, you've got arrows in the correct places, etc. So now let's consider numerical discrete data types. Okay, so you'll see that I've left my categorical chart up here from earlier in the video, but I've added this new one. This is going to be for some discrete data, numerical discrete data, siblings and frequency of people that have that number of siblings. So we can see our total here, there's 21 people that have been asked this question, how many siblings do you have? And here are the results in a frequency table. I haven't done a percentage frequency, I'm going to draw instead a column graph of frequency and siblings. Now because it's discrete data, and this is a little bit questionable, it's the grey area, but because it's numerical, we should now put this together in a column chart that's actually got a special name. It's called a histogram, and a histogram is like a column chart, but we don't have these gaps. So I'm going to leave out those gaps. And instead of those gaps, we're going to butt everything up against itself. So I'll do it in pink here. For 0 siblings, there are 4 people. So I draw my little box with 4. And then for 1 sibling, there are 9 people that responded that they have 1 sibling. Of course, you'll use a ruler and be a lot more accurate than me. For 2 siblings, there were 6 people that said that was true. And then there were 2 people that said they had 3 siblings. And this is what my graph looks like. So I can colour it in to make it look nice and make it clear where the data lies. And then what I do is I label my axes. Now, when you're labelling discrete data, you label the middle of the bar, which will be different to when we see continuous data in a moment. Of course, it might go on, and we have to be a little bit careful with the old 3+, because as soon as we create a 3+, well, it doesn't really make sense for our bar to end there. But this is the discrete, or better yet, numerical representation, where these bars meet, showing that there's nothing in between. You have 0 siblings, or you have 1 sibling, but there's nothing in between. Whereas over here, pink doesn't naturally lead to orange in that previous example. So we show a bar that doesn't connect because we're not saying that they are necessarily consecutive and nothing in between. Whereas here we are saying that. So there we have a histogram for discrete data. Pretty easy to draw. The continuous ones, continuous data histograms, are a little bit trickier, but really not that bad. And finally, numerical continuous data types. Okay, so what I've got illuminated here is some continuous data collected for the height of bean plants in a science experiment in a school classroom. So a bunch of students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students have been growing a plant, they've measured the height, this is the continuous data, measured to 1 decimal place. So because it's continuous, we have had to do some rounding. What we're going to do now is we're going to put this into a continuous frequency table and then sketch that graph. But we might do it twice just to show you what could happen here and how we could make choices. So let's do it the first time. We'll do it down here, and I'm going to group it the natural way, what we'd expect to see. So we've got 9.8 as the lowest, 15.6 as the highest, and so I'm going to group it from 9 to 10, 10 to 11, so on and so forth. So we'll have our height, and then we'll have our frequency, and our height will be, I'm going to do it this way, height is greater than or equal to 9, but less than 10. And then height is greater than or equal to 10, less than 11. So you see here we've ended up with a lot of columns. Now I'm going to fill in my frequency table. I've got 11 pieces of data but 7 sections that can go into. So this is okay, but we do need to deal with this and discuss where this leads in the long run. So I've got 1 value in the first one, 0 in the second, 2 in the third, 1, 2, 3, 4 in the next one. The next one from 13 to up I've got 2, I've got 1 and I've got 1. And then of course if I sketch this, it's going to look like this, and it's not going to be perfect because I know I'm running out of space on the video screen, but I only have to go up to 4. So if I split this in half and go up, that's 4, that's 2, and now I'm going to start out. Now this would normally be 0, but obviously starting with 0 with this set of data doesn't make sense. I'm going to end up with a big gap. So I'm going to start ahead here arbitrarily out at 9, and then I'll go up to 16. So I'm going to split this in half, split it in half, split it in half, like so, and I get 10, 11, 12, 13, 14, 15 and 16. This is my height in centimetres, and this is my frequency. Now keep in mind here, I've only done 4 and 2 there, whereas I've had all the numbers here. That was painstaking, particularly for an exam. So you need to recognise you don't necessarily need all the numbers. Now if you want to be really careful, yeah, here there's not that many, you can do it. But if you had a lot more than that, yeah, maybe we start to leave gaps. It just needs to be clear what's going on. It needs to be obvious that what the scale is, and the scale needs to be consistent as well. So you don't go up by 1 and then up by 2 and then up by 5. Consistent scale. So here's my frequency chart, and now I'm going to mark all of them. So from 9 to 10, I've got 1, and then from 10 to 11 I've got 0, and then from 11 to 12 I've got 2, and then I've got 4. That's gone a little bit far. Again, you'd be using a ruler. And then I've got 2 again, then I've got 1, and then I've got 1. Okay, so there's my graph, and I can fill it in, colour it in if I want to. You can see what's happening here. They butt up against each other because no number exists in between. Everything's accounted for. And to be really technical, I should be slightly below or slightly above due to the rounding. But in this case, I can see I've set out the parameters of what's going on here. So there's my first one. Now, the second one is a different grouping method. I might look here and go, I've really separated my data out into 7 groups and there's only 11 pieces of data, which is not ideal. So what I'm going to do instead, I'm going to do a second table which still has height and frequency, but this time my height is going to be grouped in smaller groups, or in large groups, so there's smaller number of groups. So I'm going to go from 8 to 10. And I'm going to go from 10 to 12. Well, that shouldn't be there. And then I'm going to go from 12 to 14, and then I go from 14 to 16. Every number fits in one slot. And now I'm going to do my frequency table again. But this time I've got 1 data point there, and then from 10 to 12 I've got 2 data points. From 12 to 14 I've got 6 data points, and then I've got 2 data points. And now my frequency graph, which is my histogram, will look like this. This time I have to make sure that I can make it up to 6. So I'm going to start at 8, finish at 16, split in half, split in half, split in half, which is always a good way to do it if you're estimating. Of course, in an exam, you will use a ruler. And I've got 2, 4, 6. 6, 4, 2, 8, 10, 12, 14, 16. Height in centimetres, make it clear. Frequency, there's no unit for frequency, it's just a count. And then from 8 to 10 I've got 1 data point. And from 10 to 12 I've got 2 data points. And then I've got 6 data points. And then I've got 2 data points. And there's my graph. Now, the shape of this graph and this graph should be fairly similar. See, what this has done is I'm missing the 8 band here, and this is stretched out down the 8 band. Spread it out a bit more, and it looks like it's moved that center up a little bit, which is a bit of a deception. And that's the thing with graphs and creating histograms. The way you choose to do it can change the perception of the graph, and that's how data can be misleading. But the data is accurate based on this information here, and the shape's about right. We can see that little band at the end where it's dropped down. You can see the big chunk in the middle here as we expected, and we can see the little tail down this end. So we get that quite central data look in both of them, but again a different result. So these are histograms, and continuous data histograms, they have to have a clear boundary at 10 or 12 or whatever it is, and the boundaries have to meet so we have no gaps in between. Thanks. Well, thank you for joining me on this adventure. I hope the video wasn't too long and that you got something from it. There's some really important things here that you need to be aware of in order to be able to answer questions effectively.